I wanted to talk to you about how a p-value works in a left-tailed test, a right-tailed test, and a two-tailed test. I talked about before how the p-value is the percent of possible combinations that have either your test statistic or a more extreme test statistic. I'm going to show you exactly what that means in all these different types of tests. When you're doing a left-tailed test, you're hoping to make it in this area at the, below the negative critical value, or to the left of the negative critical value. And 5% of the possible outcomes are in this area. 5% of the possible combinations are in here. What the p-value is in a left-tailed test is it's the percent of possible combinations that are at your outcome or to the left of your outcome. So let's say you end up getting this combination of people right here. What the p-value would be the percent of the combinations that have the test statistic or the t-score of your outcome, or a lower, or a t-score further to the left. So let's see right here. This is p-value would be whatever percent of combinations are in this area that are either at the t-score of your combination or further to the left. That's what a p-value is in a left-tailed test. And I talked about how the total area beyond the negative critical value is called the rejection region, and it's 5% of the area. So 5% of the entire curve area is inside here. If this area is 5% and your outcome is inside the rejection region right here, then the p-value is only the percent beyond your combination right here, which means if you're inside the rejection region, your p-value will be less than 0.05, because the slice right here, this piece, is obviously smaller than the entire rejection region, which is 5%. So it looks like the p-value is about 0.03, maybe 3%. Because if this entire rejection region is 5%, then the p-value right here would probably be 0.03. And I told you that if your outcome or your data set gives you a t-score beyond the critical value, you'll end up rejecting the null hypothesis. I also told you that if your p-value is 0.05 or lower, you'll end up rejecting. That's because if your outcome or your combination is inside this rejection region, your p-value will have to be less than 5%. And that's why the p-value is another way to find out whether you're in the rejection region. The p-value is basically just another way to find out if you ended up in this rejection region beyond the critical value. In a right-tailed test, the p-value is the percent of combinations that have a t-score either at your outcome, which means the percent of combinations that either have the t-score that you found or a larger t-score. So if this point right here is your data set and it's stacked above its t-score on this number line right here, then the p-value would be the percent of combinations that are in this area where the t-score is either equal to your t-score or larger. And the entire rejection region, which is the entire area above the positive critical value, is 5%. So if your outcome is somewhere in the middle of the rejection region, or if it's even if it's beyond the critical value and somewhere inside the rejection region, your p-value is going to be less than 5%, because this whole piece beyond this dotted line is 5%, and your p-value is smaller than that 5%. So this might also be 0.03 for your p-value. So if you're doing a right-tailed test and you end up above the positive critical value up here somewhere for your t-score, your p-value will be less than 5% because it's less than the 5% of the total rejection region. And if you see that your p-value is less than 0.05, or if you see that your p-value is 0.05 or less, then it means that you've ended up in the rejection region, and you can reject the null hypothesis. Because the area right at this critical value is also part of the rejection region. So if my outcome was right here, right at the critical value, my p-value would be the entire rejection region, because that's the area beyond my combination, and my p-value would be exactly 0.05. And exactly 0.05 is good enough to reject because it's right at the critical value. So I talked about how in a left-tailed test, the p-value is the percent of combinations at your outcome, at your t-score, or to the left of your t-score. In a right-tailed test, it's the percent of combinations at your t-score or to the right of your t-score. In a two-tailed test, it's more complicated because let's say we found this outcome up here in this positive rejection region, and let's say that the t-score ended up being 2.1. The p-value would be the percent of all of the combinations that are at 2.1 or above 2.1 up here. That's the p-value. Let's say that this percent is 0.02. What you would have to do is also find the percent of combinations that are to the left of the negative version of your t-score. The negative or opposite version of my t-score is negative 2.1, which would mean I would also need the percent of combinations that are at 2.1 or further to the left of 2.1 up here. If 2% of the combinations are at 0.01 or to the right of 2.1 up here, that means 2% of the possible combinations will also be in this area that's at minus 2.1 or to the left. Because since the curve is symmetric, the left half is the same as the right half, this piece right here has to be the same size as this piece over here, because these numbers are the opposites of each other. If I wanted the p-value in my two-tailed test, I would have to add the percent of outcomes, or the percent of combinations that are at or beyond my t-score over here at the right end, and I would have to take that number and add it to this piece over here at the opposite end, which is the percent of combinations that are either at the opposite of my t-score or beyond to the left. So if I add these together, I get 0.04, which is my p-value. And it works the same way regardless of whether you end up with a negative or a positive t-score. If my t-score ends up being minus 2.1, I still have to add this 0.02 area to this 0.02 area. I still have to take the percent that's beyond my outcome and add it to the percent above the opposite, beyond the opposite. So if I got minus 2.1 as my t-score, my p-value would still be 0.04. If I got 2.1, it would still be 0.04, because regardless of whether you end up with at the negative end or the positive end, you still have to add the two sides of the curve. You still have to add these two pieces together. So I think that explains everything that I wanted to cover in this example, or in this lesson. You also have to remember that in a t-test, you're always looking at the what the combinations would be if the null hypothesis was true, which means that if the null hypothesis is true, or you're looking at the situation when the null is true, then the peak at the center is at 0 in all three of these. So the p-value is actually the percent of possible combinations that are at your that either have your t-score or have more extreme scores inside the curve that's that would be found in the situation where the null is true. Now, what does that mean? It basically means that it's the percent of outcomes, or the percent of combinations that are in this piece that's either at your score or beyond your score inside of this curve that peaks at 0, meaning inside the curve that would exist in the situation where the null is true. Because if the null is true, if the null hypothesis really is true, then the curve peaks at 0. This is really a hypothetical curve that's you're using to do the test. It's really a hypothetical curve where the null really is true and it peaks at 0. And if your outcome ends up in the rejection region, it means you found an extreme outcome in the situation of the null hypothesis, meaning you found an outcome that would be at the extreme end of the curve in a situation where the null is true and the curve peaks at 0. So it basically means you found an outcome that seems too extreme for the null hypothesis to really be true. You found an outcome that's very extreme or very unlikely to happen in this situation where the null is true, which also means it's an outcome that lets you reject the null hypothesis. If you get an outcome that's unlikely to be found in the curve where the null is true, it can be taken as evidence that the null really isn't true. I hope that makes sense. If you have any questions, you can just feel free to ask me.